Hello, and this is Module 7, Lesson 1, which is Surface Water Movement. So the focus question today, what I want you to think about while you're listening to this, is what happens to surface water that does not soak into the ground? So where does it go? All right, so if we're looking at water moving into the ground, water is going to be carrying a lot more than just water. And so it'll be carrying things that are dissolved. And so when they dissolve, they're called a solution. So here's an example of a solution: water mixed with salt, and then that salt dissolves and you can't see it anymore. It's not bonded with the water. So if the water were to evaporate, the salt would be left behind. But that's a solution. It's a homogeneous solution, homogeneous mixture, which means that you can't see the difference throughout. All right, so looking at the hydrosphere is all the water on the earth. So hydro refers to water. So about 97% of the Earth's water is contained within the oceans, which is pretty amazing. That's kind of why we're called the water planet. And then only about 3% of all the water on Earth is actually fresh water. So out of the 97% of water that's contained in the oceans, on land, everywhere, only 3% of all the fresh water or all the water on Earth is fresh water. And out of that, only about 1% is readily available for us. So pretty amazing, pretty good reason right there just to conserve fresh water. It's really hard and really expensive to convert salt water to fresh water. So that is definitely a last resort. All right, so the water cycle, pretty standard. You probably learned this back in, I don't know, second grade, third grade. So it should be a review. But so you've got evaporation occurring, then condensation, then you've got precipitation, runoff. Here we've got our river going out to the ocean. And so the only thing that maybe a couple words that you might not recognize would be transpiration. So this is actually extremely important. This is plants giving off water vapor through photosynthesis. So that's called transpiration. And then infiltration is when it goes into the ground. So it infiltrates through the ground. So these two words, definitely need to know what those are, and know generally just how this works. All right, so if we look at this runoff, um, it's definitely raining hard or has been raining hard for a while or just raining a lot. So you can see runoff occurring on this land, and it's kind of filling in down here at the bottom. And so it's infiltrating into the ground. But if the ground is already saturated, meaning that it can't hold any more water, then we get runoff. And so you can see there's lots of runoff here. This ground looks extremely saturated. So it really can't hold any more water. So it just starts to run down. If it rains heavily, then what happens is we start to get rills and we start to get erosion occurring, especially if there's not vegetation. So this hillside has a little bit of vegetation, but really up here, I don't see a lot. And so that's going to start to cause erosion because the roots are not holding that soil in. All right, so I said that the ground could be saturated. So that depends on the amount of pore space. So we've got pores in the sand grains. We've got quite a few pore spaces. This is silt. And so silt, remember, is a little bit smaller than sand. And then what we have is this is silt and sand mixed together. So what happens here is the pore spaces are very small. And so you don't get water moving through very good. So if they're sorted, meaning that they're the same size, then water can move through a lot easier through the sand or just the silt. When it's mixed together, what happens is those little pore spaces get clogged. And so then don't get water moving through very easily, and it causes flooding, basically. And then the clay is even smaller than these. So clay virtually has no pore space. So if you think about our soil here, water doesn't go down into the soil very easily, and that's because we have a lot of clay. And so clay really takes a long time to absorb water. You'll see a lot of erosion, a lot of runoff with clay versus sand. All right, so this is quite a bit of runoff there. So this is definitely very saturated soil. And so it can't hold any more water. All the pore spaces are full, so you'll see lots of runoff. We see this here, especially if it rains really heavily, even if the ground is completely dry. And that's because, like I said, our clay prevents water from going down. It has to sit on the ground for a while before it infiltrates down into the ground, versus this sod or this more fertile soil. It can run into the ground easier, but if it's full, then it doesn't really. All right, so lots of runoff here. And so definitely, I mean, this is just common sense, I would think. But the steeper the slope, the more runoff, the faster the water flows. So the more erosion can occur, the more water doesn't go into the ground, but actually just runs off. All right, and then here's looking at watersheds eventually here. This is a water system, so this is a river. And then all of these little tiny fingers that flow into this main branch are tributaries. So this is the main river here, main river channel. And then all these little fingers, even though this one's bigger, it's all a tributary to this larger body of water. So the Sacramento River is our main water body in the North State. And then we've got all the different rivers and streams that flow into it are all tributaries of the larger Sacramento River. And then we did a lab on this, but this is a watershed. So here's our ridges. And then all the precipitation that comes into this area flows down into the lower areas. And that eventually flows into these little tributaries here and then into the main water source, which we could think of as the Sacramento River. And then it flows downstream, eventually comes out into the bay. So that would be our watershed. And then the divide is basically just where we've got our ridges. And so there's a different watershed, different drainage basin on this side here. So here's some major drainage basin of the Mississippi River. Mississippi River is huge. And there's a reason, and that's because the drainage basin is huge. So you've got the Missouri River, which is a good-sized river in itself, is in a sense a tributary of the Mississippi River, which is much bigger. And then we've got the Ohio River flowing in and a bunch of different rivers flowing in eventually to the Mississippi. But all of this water drains into that river. So it's a huge river. And this continental divide, this is the Rocky Mountains basically. And so this is the highest point in our continent. So all the water on this side drains not necessarily all into the Mississippi River, but it drains that direction. And then along this way to the west of the divide, it drains generally to the west. And we've got a couple different rivers here. We've got big rivers. We've got the Sacramento, San Joaquin. We've got the Colorado that kind of flows like this down. And then we've got a bunch of rivers up in the north too. All right, so as rivers move, they move the load. And so the load is what it's carrying. So these are things that could be in suspension, it's things that are moving along the bottom. So there's a different terms for this. And so saltation, just like with sand dunes, it's when the little grains are bouncing along. So they're not in the water like floating around. They're kind of at the bottom and they're kind of moving and bouncing and tumbling. And that's how we get our rounded rock in the river. But that's called saltation. If it stays on the bottom and hits the bottom and kind of slides along, that's traction. And then if it's actually up in the water for a while, that's suspension. So our lighter stuff like silt and clay will be in suspension. Our heavier stuff will be down at the bottom. And you can see this is two rivers that join. And this river isn't carrying much. You can tell just because it's not muddy and murky. And this one has a lot of sediment in suspension. So there's, if I just look at this picture, I can tell the river that's coming from the right, there's quite a bit of erosion going on there. Whereas the river on the left might be going through more rock terrain. And so it's going to be clear and not holding as much. If you've ever been near the Trinity River, if you're going towards Eureka, it's very clear. You really don't see a lot of sediment. It's up in the mountains, so it's having to flow over a lot of rock. Whereas the Sacramento River is flowing over a lot of soil, especially in the valley. And so you'll see the Sacramento River, especially in winter, look very murky, whereas this would be more of like the mountainous Trinity River. All right, so the bed load of a stream is what it carries. So if it's flowing fast, it's going to have a large bed load. It's going to be carrying a lot more heavier things. If it's flowing slow, it's not. So it's not going to be carrying as much if it's flowing slow because it just doesn't have as much energy. So when it's fast in the winter, you'll see a lot of suspended material. It'll be kind of dark color, kind of murky looking. And then the summertime, when it's flowing very slow, it'll be more clear. And you'll be able to see the bottom, like the Sacramento River, because it's not carrying as much. And so the faster it goes, the more of this bed load it carries. All right, and then once it gets to its source, its discharge is the amount of water, the volume that stream is carrying. So a small stream is going to have a small discharge. A large river or large stream will have a large discharge. And we measure discharge it's a volume measurement. And so it's how much volume per hour or per minute is flowing in that area. So here's how we measure it. So we look at the average depth, average width, and the velocity, which is the speed and direction. And so that's how we can calculate how much it's carrying. And that's really important, especially when we're looking at lower lying areas for flooding. So if we look at the discharge, that can tell us, if people are at risk for flooding, especially towards towards Sacramento, where the river, we've got all that huge watershed dumping down into that area. So that's pretty important to determine if things are going to be okay or not. All right, so here's our floodplain. So the Sacramento River has a huge floodplain. It's basically the Sacramento Valley, and so that's why the Sacramento Valley is so fertile. Is because before the dam was built, it used to regularly overflow its banks, and it's carrying. Think about all that bed load that it's carrying. So that is very silty, good soil, and eventually makes really good soil. So when it floods over, it deposits that because as it floods over, it basically slows down, and so it spreads out all of that material. So here's the floodplain, and it's basically just a flatter area. So this river is meandering around, and so basically it's if it's a lots of discharge, lots of rainfall in the mountains coming down into this area, it'll eventually maybe flood this area. And so you can see during flooding times, it's flooding this whole valley. And it still even does that, even with the dam. We get the Sacramento River overflowing its banks sometimes. And so doesn't do it as much as it used to, and that's because of the dam. But also, it's not depositing that rich soil anymore either. And so that's kind of a downfall to that. All right, so here is showing kind of a seasonal. So if we look at floods, here's our normal river. This is the floodplain. You can kind of see that if you go along rivers, you can see that there's an area where it looks like the river has been higher at one point. So that's basically its floodplain. And rivers that are wide, like the Sacramento, it's going to have a huge floodplain. Rivers that are small will have a smaller floodplain or narrow. So it just depends on the topography. And so you can see sediment gets deposited during the flood. And then now it's building up natural levees. So you'll naturally get like banks on the side. And that's just because it overflows maybe in the winter. And then in the summer, when the water flow, the discharge is less, then you'll get that being exposed. And you won't see trees and things on there. Notice how the trees kind of disappeared as these natural levees are built. All right, so it's in the flood stage when a river gets to be higher than its bank. So if we go back to this picture, this would be our flood stage. This is our normal. This is our normal. So our flood stage is basically just when the river is flowing up to its natural levees, and that's just from heavy rain, heavy accumulation of all the streams dumping into it. So the bigger the river, the bigger the watershed, the bigger the devastation, I guess, from flooding would be. All right, so we put out flood warnings when we look at the discharge. So we're measuring discharge. We're looking at the amount of rainfall. Remember the video in the last set of notes, the watershed that we saw the rooftop. They talked about the roof in that area. Just that was 93 gallons of water just coming off that one watershed on the roof. So pretty significant just for a small little area. So think about the whole Sacramento Valley. So when we're measuring all the little streams discharge, we can tell if there's going to be a flooding event or not. And so they'll issue a flood warning. So living here, we get lots of those a year where small little streams might overflow. You need to stay away from the Sacramento River banks because it's flowing very fast and rising. And so they just warn people that that's about to happen. And that is it. I hope you enjoyed.